Hello, welcome back. Today let's try to solve another Leetcode problem. Number 2251, number of flowers in full bloom. So let's read the questions first. So we are giving a zero index to the integer array flowers. So this in flowers means from index, yeah, it's a zero indexed array, but here is just a label. For example, from label 1 to 6, so this is 1 to 6. So we have the full bloom of the flowers like this, 1 to 6, and 3 to 7. Here we have 3 to 7, 9 to 12. So this is 9 to 12, and this is 4 to 13. So what are we going to return? We need to return an array. So this array is decided by the people array. So the people array means the people is sitting at this position. For example, this is 2. So the people will be at the position 2. For this position 2, actually it is the index 1. And also for the flowers, if it is 1, label 1, it is the index 0. For the 2, it is the index 1. So at this index, how many flowers can these people see? It means only 1 flowers. When it is in position 3, so there are 2 flowers. When it goes to position 7, there are 2 flowers. And when it goes to 11, there are 2 flowers. So this is what we're going to return, the output 1, 2, 2, 2 for this array. Now let's analyze the problem. If we use the difference array method, we have to check what is the length of our difference array. Yeah, but here, as we can see it, the peoples.less is 5 times 10 to the power of 4, it is okay. But for the start and end point, it is 10 to the power of 9. It means it is not possible if you use a difference method. Yeah, difference array method. For example, just use f0 times, like 10 to the power of 9. Because the start point and end point should be at most 10 to the power of 9. So this is why you need to use the f function like that. But this is not possible, because it will be memory exceeded or the time exceeded. But yeah, we should use a better way to solve the problem. Now we can use another way. It's similar to the difference array method. It is called sweep line. The sweep line means, for example, this is flowers, and for the flowers we can use a line to sweep, like this point and this point and this point, and here this 9 point. We're gonna sweep the start point and end point. When we come across a start point, we're gonna plus by 1. When we find an end point, we're gonna minus by 1. So plus by 1 minus 1 plus 1 minus 1. Yeah, like that. But even we use this way, we have to check through 1 by 1, but that is even takes that is not easy to do. Why we check the people directly? For example, if people at position 2, it is at this position, we just need to check the start point. How many start point before position 2? As we can see, there's only 1. And how many end point before position 2? So there's no end point before position 2. It means the result will be 1 minus 0. It is 2. Yeah, because for the start point, we know this person has already seen flowers, but we don't know if it sees it or not. We have to check the end point. So if the start point and end point always be at label 1, it means this person cannot see these flowers. So this is why we have to check how many start point before this label 2. For example, this label 7, we're going to check how many start point before label 7. We can find 1, 2, and 3. And then we're going to check how many end point before this label 7. How many? So there's only 1. This 1 is before the label 7. So what is the result? It is 3 minus 1. It is 2. That is why for 7 it is 2. Yeah. So if it is like this, we have to sort the start point and end point first. If we are going to sort it, so the time complexity is only n log n time. Yeah, let's check how many start point and how many end point. As we can see here, the people's length is 5 times 10 to the power of 4. So n times log n, it is okay for this kind of numbers because it is not 10 to the power of 9. 5 times 10 to the power of 4 is okay. Now, let's try to sort the start point and end point inside the flowers array. So we're gonna define a start should equal to sorted, and inside should be an array. So the array would be S for start add in flowers. So this means that the start point have already been sorted. Similarly, we should also sort the add point. Let's define an add array. The add point should be E means add for start add in flowers. Yeah, after the start point and end point has already been sorted, we can just check this person, how many start point before this person and how many end point before this person. Then we can solve the problem. But for the start point before this person, we should also include this number. If there's a flowers, this should also be included for the start point. But for the end point, these flowers at the same place should not be included. For example, at this place, we've already saw two flowers. This means for the start point, these two flowers should be included. Yeah, as you can see, it is 1 and 2. For example, at prison, let's have another example. At prison 5, at prison 6, for example, how many start point? We can say 1, 2, and 3. And how many end point? And for the end point before this prison 6, so there's no, because there's no end point before. This prison is equal to 6. It's not counted. Yeah, only before. So it is 3 minus 0. So it means 0. As we can see here, from here we can see 3 flowers. Yeah. For example, at this prison, how many start point? 1, 2, and 3. And how many end point? So there's no end point. So this is why it is 3. Yeah. Now we are going to count. How can we count it? We can use linear method to count. It is used basically on time. Yeah, because the length of the array n is also okay. But we can also use a binary search to search it. Yeah, binary search is much faster than this linear time. If we use a linear time, let's check. For each flowers, it will be 5 times 10 to the power of 4. And how many points? The flowers dot last. It means 5 times 10 to the power of 4. It is 25 times 10 to the power of 8. It means it's impossible. We have to use a binary search to check how many flowers before this person. For example, how many flowers before this person and how many start point before this person and how many end point before this person. Now let's try to write the binary search method. So for binary search, we can directly use bisect. So for the start point, we should use bisect right for this start array with the target value, and minus the bisect left with the add array and the target value. So this target value is inside the people. Now let me explain why the bisect right should be the start point. Yeah, so for the right array, for example, we have the flowers array. It is like this. After sorting, we have a start array. The start array will be equals to 1, 3, 4, and 9. So this is the start array. And similarly, the add array should be let me equal to this place, and should be equal to 6, 7, 12, and 13. So this is the start point, this is the end point. If we are going to find a number, for example, we are going to search maybe 3. The people is at prison 3. If we are going to search 3, so this 1, 3 should be counted as at the left side. For example, the people is at this index 3. So if we gonna use this position, so how many flowers? There are 2. So this is why we have to use a bisect right, because we're gonna count this 3. So 1 plus 1 and another 1, it is 2. This is why we're gonna use a bisect right. Because if it is at 1 and 3, yeah, and people is also here, as we can see that. So this start point is at 3. We're gonna count it as 1 because this is a flower. So this we're gonna count this start point even it is at this position. And for the end point, we're gonna use a bisect left add. Yeah, and let me give you an example of the left end. So for example, we're gonna check at position 6. Yeah, so at position 6, how many flowers before it? Yeah, we have 3 flowers, 3 start point before it, so it is a 3. But how many end point just before it? So for the start point, it can be equal, but for the end point, it cannot be equal. For example, we're gonna check the number 6. So 6 is at here. So how many end point? So this end point is still at the same position, but it will not be counted. So that is why we're going to use a bisect left for that. Because if we use bisect left, the index is 0. If we use a bisect left for 6, the index is 3. If we use a bisect, if we use a bisect right for the 6, for the start array, it is 3, index 3. If we use a bisect start for the number 4, so the index is also 3. So it means for the bisect right for the start array, so the same position should be included, but for the end point, it should not be included. Otherwise, we're gonna get the wrong result. So this is why we're gonna use the bisect left for the add array and bisect right for the start array. Now let me run it to check if it really works. And as you can see, it works. And basically, this method is the sweep line method. But for the straightforward sweep line, we're going to sweep one point by another and then count. But here, we get the final result just to check how many points before it and how many end point also before it. So in this way, we can count in total how many flowers we can see. So for example, here we have a person at label 5. This is 5. And if we count 3 points before him, it means at least we can see, maybe we can at most see 3 flowers, but it's not like that. We have to check the end point. If all those end point after this label 5, it means this 3 is okay. If some flowers add earlier, it may add at label 4, it means we're gonna minus by 1. So this is the idea to solve the problem. Now let me submit it to check if it really works. Yeah, as you can see, it's pretty fast and it really works. Now let's analyze the time complexity. So for the first one, the start is for sorted the array. So for this time, let's check the length of the flowers. It is 4 times 10 to the power of 4. So it is n log n for this one. And also for the second add array, it's the same. And now let's check the bisect right and how many t's. So for the number of people, how many people inside the people array, let's check. So it is 5 times 10 to the power of 4, let's name it n, and times for the bisect left. So the bisect left is for the start array. And what is the length of the start array? So flowers, yeah, let's check the length of the start array. It is also 5 times 10 to the power 4. Let's name it n. As you can see here, the time complexity is also n times log n. Maybe 2 times n times log n, but it doesn't matter because we have 2 bisect Yeah, but it doesn't matter. So the final time complexity is n times log n. So this n is 5 times 10 to the power of 5. That is why it's so fast and it can pass all the testing cases. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more LeetCode problems like this. See